We all assume that you read it and understood it. I heard someone saying earlier today, it basically just says that anything you say during the week in Dallas is part of the IETF proceedings. It is to overstate a bit, I guess. This is to overstate a bit, I guess, but note well applies to anything you do in the capacity of as an IETF participant. Next slide, please. So we have two meetings. Meeting starting now, and we have one on Friday, starting 10 minutes to 12. I don't know why we got the extra 10 minutes. Next slide, please. Here is the proposed agenda. It's actually just listing the drafts that we're going to discuss. So, unless there are any proposals for changes or new items, I think we should go ahead with the agenda as proposed. Okay, let's do that. Blue sheets. Ross has been handing out the blue sheets. Start circulate them, put your name on them, don't write Donald Duck more than once. And keep them moving and get them back to the working group chairs, or actually to Tarek once you're done. Go back one slide. Have you? Okay, fine. Oh, too many drafts? Okay. So we are, and next slide. So we have had an ongoing tuning of the routing area. We have published a new set of charters that actually covers the border between the TEAS working group and the Mpls working groups. They have been published, both of them, I think, since Honolulu. And we also, where is Deborah? There is Deborah. Deborah is going to take over, from a formal point of view, she's going to take over as a responsible AD for the Mpls working group tomorrow night, but we're already treating her as she's responsible, so please welcome Deborah.
Yeah, well, we will be bidding Adrian farewell as our AD after 6 years of fabulous service, and I think we ought to all thank him for his thorough reviews and guidance in this work group.
So there are, so you should know there is a continuous discussion on where drafts should go between the TEAS working group chairs and the Mpls working group chairs. Currently we have sorted them as we have, and we will discuss them as such. If you want to change that, give us a mail and tell us that we've done something wrong on that. We will have Mpls-related young model discussions on Friday, and that's actually the first part of the meeting on Friday. And then I have something that I want you to be aware of. We talked to, in fact, actually should start a little bit further back. We had a problem. The mail alias for drafts was actually copied onto a mail alias where the working group was already part of the so when mailmen started to count how many addresses are there, they actually held them for moderation. So now we talked to Glenn and Matt on IMS, and we agreed on it. We will raise the level of numbers of addresses allowed, and we will also allow indirect addresses. So we will put the .all back on the mailing on the MPLS working groups again. This will increase the number of mails you will receive on the mail list, and you need to scream if it gets painful. Some of Eric can scream anyway. Some of it is mails that are very hard to understand if you don't need, if you're not the person that did the action that caused the mail, you don't understand what's in the mail. We're working with those people to actually improve the quality of the outgoing mails also. But look out for number of mails. Next slide. We had one errata. It's verified, and it's on a fairly new RFC. So if I go to the next slide, the slide that had the errata is the first on the list. So it's the errata on a document that's actually been published since Honolulu. We've done 7 new MPLS RFCs since Honolulu. We have, next slide please, another 5 that is fairly close to be RFCs. So we are keeping up the good work in this respect. I'm not going to go into detail. If there is anything you want to ask about this, do that at the microphone or actually send us a mail. Next slide. That one. One hint here. If anything is blue on the agenda, then it will be blue on the status slide. It will be discussed on the agenda. So we have 5 documents in ISG processing that they are close to IETF last call or actually being discussed after IETF last call. We have, I haven't counted on this time, but we have a number of working group drafts. Many of them have come in. We are missing reports on some of them. Most of them says that the work is going on as planned, and where we see that it's actually discussing is slowing down, we'll start pinging authors and see if they are ready to go to working with class call. We have one document, should be 2 documents here. The 2 last on the list are in working group last call at the moment. So that's the one of the last MPLS TP, larger MPLS TP drafts, and the other one is an update to L2 ping.
Lowell, can I just quickly say for those last 2 drafts that, well, when I last looked, which was a couple of days ago, we hadn't had any comments yet. Admittingly, one of them had only just gone to working group last call, but I'd like to request that people read the documents, and if they support them, comment on them, and if nobody supports them, then I'll take that into consideration.
They are, both of them are like more than a week after the IETF week, I think.
One of them, the working group last call ends next Friday, so, you know, and then the other one the Friday after that. Whether it's either Thursday or Friday.
So we probably should send a reminder.
Yeah, I intend to. Yeah.
Next slide, please. Again, we have on this slide, there's a draft called MPLS TP temporal hitless PSM. It was very, very close to be sent where we were close to sending the publication request. So we were through working group last call, and then the editor defected, and I haven't been able to locate him since then. So now we have a new editor and new people working well, same people working with on the draft in different roles. So that should move ahead also. And on the non-working group, next slide. Yeah. So here are the documents. Basically, most of the documents we will discuss today. One of them has actually been moved. We got a request for something what was an Mpls working group document, but it actually moved. We have one document that actually been merged into another, and we have that's the BFD enhancement. The source label draft is pending work together with authors from some other drafts, among others. And then we have, next slide. So there are, I think we're wrong here, Tarek. Draft FANG actually have the slides in. It still says missing. So that's wrong. And then we have one of my favorites, because it was my AD that was one of the co-authors together with another AD. And we never really think I cleared out what our differences were. But this is an experimental draft. It's the opportunistic encryption. And what the author says is that nothing must happen. It's been updated. It's been improved. The thing I want to see, I want to see a good discussion whether we should take it on as a working group document or not. So that's and as I understood, the authors at one time was that they wanted to do the have an experimental implementation for us, but that turns out not true. They are.
Adrian Farrell. Yeah, we do want to have experimental implementations. We don't believe that that is gated on being adopted.
Or the other way around.
Or the other way around.
Yeah.
We do want comments from the working group. We don't believe that that is a prerequisite for adoption or the other way around. We're not pushing for adoption at this moment. But if you decide it's in scope and you want the working group to have control, that would be just fine.
You won't resist to be adopted?
No, no.
Okay.
Resistance is futile.
Yeah. So, next slide. We have a few drafts on this page. If you are a co-author on those that says no update, please let us know where the documents are in status or how you want to process them. I have a particular interest here, and that's the domain-wide labels. I would like to have a report on that. Robert, are you here? No. Okay. Next slide. You have Tarek, you have a slide missing again on Rasa. Is that still true? That's a Friday. Okay, so we have to fix that. Other than that, we have a Mpls beer encapsulation. What I put on is waiting for the beer working group to start. It has started or will start this week. So we can probably make some progress on this as soon as ICE is ready to move it. And the last slide. This is liaisons to and from the Mpls working group. So we have 3 incoming liaisons. Basically, they are study group 15 telling us what they plan to do. And we have 1 outgoing. Sorry, we have. I don't know really. Maybe Scott knows, but we have at least one outgoing liaison that is joint response to two of the liaisons incoming. And the target here is for the study 15 meeting in June. We will compile a response and then we will circulate it to the appropriate working group mailing list. So I'm done. It's free, isn't it? I have one thing. Sometimes the work as a working group chair is impossible because there's a sign up here that says make sure that the presenter keeps within the pink box. And when you go look, the box is white. So keep it within the box.
Okay. All right. So this draft just became a working group draft about, I think, 2 to 3 weeks ago. Next slide, please. So I'm going to give a brief summary on what are the updates that have happened since the last IETF. As a background, this draft is about load balancing in segment routing when using the Mpls data plane. And more specifically, it's about how to use RFC 6790, which is the entropy label RFC, to do load balancing. So the major changes that have happened since the last IETF is we have addressed the remaining Mpls RT review comments. And as a part of addressing those comments, we have changed completely one of the use cases that was there in the draft. Previously, we had a service chaining use case using service SIDs. That has been changed to a traffic engineering use case. And we've also improved the readability of the algorithm that generates the positions at which entropy labels should be inserted in the label stack. Next slide, please. So in this use case, the new topology that we have is you have nodes LSRs P1 and P3 with parallel links between them, and LSRs P2 and D with the ECMP paths between them. The requirement to route the LSP from the source to the destination is to go through the link L1 and to do load balancing, to do good load balancing on the two parallel paths. Now, the hardware limitation or the constraint of LSR P1 is that it cannot look deep into the label stack. So it does not encounter the entropy label if you put just one entropy label at the bottom of the label stack. So in order to get around this problem, the recommendations, set of recommendations have been provided, and as a part of that, you end up with having multiple ELI ELs in the label stack, in this case 2 ELI ELs. So the ELI EL at the top, the one that comes just after the label to the node P3, would be used by the node P1 to do load balancing on the parallel links from P1 to P3. Next slide, please. Lastly, some of the related discussions that have happened. One of the discussions that we have had is whether it makes sense to make the readable label depth parameter, which is currently node-wide, whether it makes sense to make it interface specific. Now, this introduces significant complexity into the solution, and the benefits seem to be fairly minimal. So we don't have a strong use case to address this problem. We would like feedback from the room or on the mailing list on detailed reasons why and if we need to address this problem. The second discussion that we have had is regarding OAM. And the OAM requirements for segment routing are still very much under discussion. But this proposal to introduce multiple ELI ELs in the label stack does not seem to have any bearing on any OAM specific procedures that need to happen. So this is another item that is still under discussion. and that's pretty much it.
Questions? Okay, thank you. Next is Kishore.
Hi, my name is Kishore Trividula. Today I'm going to talk about the MLDP MIB. Next slide, please. I'm going to briefly touch a recap of the MLDP MIB tables and scalars, and then the changes made in this version, and finally the next steps. Next slide. So this draft was presented in the IETF 89 at London. So after that, a few changes have made. So, but before going to the changes made, just I want to recap of existing LDP MIB. So what is the need for a MIB, for MLDP MIB? There are several service providers are interested. They deployed different MLDP features like P2MP, MP2MP, LDP-LSPs, and MLDP in-band signaling. And there are other features that are going to deploy like MOFRR, node prediction, traffic statistics. For all these things, they are interested to use the MLDP MIB. As they are already using the LDP MIB to get the LDP related information, they are looking similar MLDP information from their network. Next slide, please. So these are the scalar objects. The first two are the P2MP and MP2P capabilities. The next two are MBB capability information and MBB act time. And the next two are related to number of FECs, MLDP FECs established, and next one is active FECs. The last four are relating to node production. So basically node production capability information, PLR cable, MPT cable, and prod cable. So all this indicates whether the LSR cable of node protecting the MLDP cases. Can you, next slide please. These are the MLDP tables. So the LDP peer capability table, which tells capability information about the P2MP and MP2MP, which this is augments the LDP peer table, which is already exist. And the next one is session stats table. This is also augments the LDP session, but this table contains the MLDP related session stats. The next one is MLDP FEC table. This is all contains the MLDP related FEC information, which contains the opaque information. The next table is MLDP FEC branch traffic stats. Basically, this contains the number of packets, bytes sent on the downstream interface. The next table is the upstream sessions table, which has the information about the upstream information. In case of MOFR, there could be two upstreams. So one is the primary and the other one is backup. So this tells which is the primary, which is the backup. And the last one is the traffic statistics table, so which tells the number of packets sent and received on the interface specific to MLDP. Next slide. These two notifications, MLDP FEC up and down, whenever there is a FEC goes down and up, these notification will be generated. Next. So this is the change made in this version. This is another notification was added, MOFR status change. Basically, this tells whether the upstream session went changed from primary to backup and vice versa, so that operator will know that where the traffic coming from. Is it coming from primary or is it coming from backup, or a switchover happened between the primary and backup. So next up, we'd like to get more feedback from you all, and so that to do this, any missing pieces, then we can add more scalar objects or more tables, notifications, anything. And we like to request working group to adopt this as a working group draft.
Kiriti compiler. Is this a read-write map or it's a read map?
Yeah, all are read-only bits.
Good.
More questions? Okay, since you are asking for working group adoption, we will start the pre-process of that to see where it goes.
Okay.
Next one is George.
I'm outside the box.
You're outside the box.
Yeah, but I spent most of my career out there, so. So this is LSP ping relay reply, and it's had quite a storied history, which I'm not going to go into all the details of, but it got close to being an RFC, and then it came back to the work group. And when I say back to the work group, I mean fully back. We're not going to skip any process going forward. It's going to go back as if it was just a regular working group document at this point. Next slide. So a significant number of changes have occurred since the last draft. The LSP ping echo reply stack object, we added two fields. One is the source address of the replying router, and the other is the destination address pointer, and I have a slide each on those two items. Then there's the echo reply stack entry had both a type and a length, but the length is strictly implied by the type, so we eliminated that field. The relay node address stack description, there was a lot of procedural language in with the object definition. We moved most of that out, except where you needed just a tiny bit in order to understand what the thing actually was. And then the MTU exceeded error, it was specific to a single object, and it seemed that we could apply that to a lot of objects. There are a lot of objects that will blow up in size long before that one does. So, so I wanted to make it general. That doesn't mean you can apply it to other objects until we write an RFC saying you can, but that's what we did there. Next slide, please. Eric? Oh, yeah, I didn't see it. On the procedures, we updated a lot of text, and there are both technical and editorial changes. And also I changed a whole lot of the shoulds to musts. There are a lot of places where I couldn't figure out why it said should. There are a lot of shoulds in LSP ping because you're never obligated to send a reply, because you may be configured not to do it, or you may be in an overload situation, in which case you throw off load that isn't essential to getting your forwarding plane correct. But where you are going to send a reply, there are some things that you must do in order to make that reply worth getting. And then in section 4.7, just changed a little bit of procedures to reflect how the source address comes back to you. And section 5, we updated it to follow new procedures. So I'm not going to say any more about those two sections, but I have more slides on all the rest of it. Next slide. So we added the address type and the source address, the replying router, into the upfront and out of the stack. And then also there's a destination address pointer added, so that the header of this object is changed quite a bit. Next slide. So the source address of the replying router, there is a semantic problem and, and serious technical problems with it. So the procedures mandated that you put in the address of the interface that you received the packet on, or that you're going to send the reply out. And you had to put that at the bottom of the stack. But there's some cases where, if you look at ASBR2, he's supposed to put 10.0.0.2 at the bottom of the stack. But when it gets over to ASBR4, he probably has no clue of how to get to that particular address. In fact, that address may appear somewhere in his own network. So bad things can happen. So we moved that out of the stack completely because it didn't make sense to have it in there, and that went up in the header. And what we did add to normative language in the draft itself is that you must put in the address that the packet would have gone out if you were forwarding it rather than having it TTL expire at you. So next slide, please. Huh? Oh. Yeah, I meant to delete that bottom thing. You see, the next slide I did, and then I didn't go back to the previous slide and get rid of it, sorry. So the other was that in the stack, the way that you processed it to find the next hop address started from the bottom of the top of the stack and searched down for a routable address. Well, it's possible you could find a routable address that you can't actually route to before, because there's these k-bits and you're supposed to route through all of them. So now it just says go up and find the first k-bit, and then starting with that, find the first routable address. So you make sure you don't get it. Otherwise, some PE2 could be looking for 10.0.0.1. He'd start at the top of the stack and he'd find 10.0.0.1 over there. And actually, in that particular case, it'd probably work okay. But if it had been some other address that was in his network that was, off the path, then bad things would happen. So what we did is instead of relying on matching addresses to find out where you were in the stack, we put an explicit stack pointer. So every time you send to address, you set the pointer to the address you just sent to, and then you look at that address, and based on where that's located in the stack, you go up to the next k-bit and then look down for a routable address, first routable address, and send it to that place. Next slide, please. So, as I mentioned 2 slides ago, that output interface, it's now a must, whereas it wasn't even mentioned in the normative text of the document. It wasn't mentioned in the example, but I didn't feel like that was sufficient to give most implementers enough impetus to actually do it. And I also added text that if you are hiding your address and replying, then you must put in a null address and set the k-bit, so that people know that you've done something that could well cause you to not get any further pings. So if you start pinging one node beyond that and you never hear anything, you can probably quit right there because it's just going in the bit bucket. Next slide, please. I think I mentioned all that while I was talking about locating addresses. Next slide. So the process from here going forward is going back through the working group review, and that request went out on March 7th. Excuse me, I got that backward. Work group review, I'm asking everybody to do that. Starting March 7th should be down 1 bullet. And so the review team has already been, we've already been selected, and we're getting comments back from them. So after we get comments from everybody, we'll address it, and then go back through a last working group last call. That's it. Any questions? Thank you. Yeah, I'm outside the box, like I usually am.
Kiriti?
Thanks to me. Yes, because I've had enough to drink and it looks pink, and so I'm going to stay inside the pink box. Ooh. Try making it smaller. Oh, there you go. Okay. Yeah. Okay, so there are a couple of drafts I want to talk about. One is the RSVP T multipath. So this is a joint work with a few people. There's a guy from Lynx, and Ravi Singh has also joined this. Next slide. So this draft has been around for a while, and we've made a fair amount of progress. We started off with something that was a completely new session object, and there was feedback saying you don't need to do that, you can use the association object. So we've changed that, and then we've added some bits, because at the end of the day, this is to have multiple LSPs to do ECMP under sort of one umbrella cover. So the association object lets you put them all, lets you associate them whenever they happen to come back together at some intermediate point. But having said that, when you fork out again, you might want to know how to allocate bandwidth among the different LSPs. So as hints to how to do that, we added one bit right now, but we'll probably add some more. So we have an implementation of something like this. Essentially, if you ask for an LSP from point A to point B, and let's say it's an 80 gig LSP on a 100 gig infrastructure, it'll be very hard to place that LSP. So we will allow automatically breaking it down into, say, 4 by 20 or 5 by 16 or whatever fits, and create under the cover these 5 LSPs of 16 gig each, and compute the path and signal them. But they're just 5 independent LSPs, and some of the value of knowing that they belong to the same sort of overall, what we call a container LSP, is lost because you don't have that information. And that value includes being able to do a better job of fast readout, or effectively fast readout. So if I have a point where 4 LSPs are leaving this point, and one of them fails, my fast readout action is just load balance across the other 3 more aggressively. So instead of sending a quarter of the traffic on each of the 4 exiting LSPs, put more traffic on the existing LSPs, and you've taken care of the one that's no longer there. So things like that, you need to know that all these LSPs are related. Another one is if I have a lot of ECMP paths that I want to cover, the number of LSPs can be a product of all the ECMPs along the way. But if you use this draft, you can have fewer LSPs and still cover all the combinations. So those kinds of optimizations are not available unless you have this association between the LSPs. So there's been good feedback to this idea of taking a biggish looking LSP and breaking into multiple smaller ones and signaling them. But the fact that they're independent doesn't let you fully exploit this. Next slide. So a couple of requests. One is early IANA code points, code point allocation for the association object and for the equal bandwidth bit in the attribute object, just so that we can start playing with implementations. And I don't know what the procedure is. You seem to say there's a fairly elaborate procedure now, an MT review, an MPS RT review, or whatever, but start the process for adoption as a working group document. So, questions? Does anyone remember the draft?
So,
Yeah, go ahead.
Himanshu Shah from Siena. Do you have, can you do asymmetric, like 20 and 25 and?
Yes, so you mean non-equal cost multipath. Actually, weighted, what we call weighted ECMP. So you can do lots of things, and part of it depends on how you do the computation. But in the data plane, you can say, I've got 4 LSPs leaving this point. They're all part of the same container, but I don't necessarily want to put the same bandwidth on each. So the idea then is to, if you signal, say you're still looking for this 80 gig LSP, but you put 20, 20, 40, or no, 20, 20, 30, 10, presumably you want to do unequal cost, or not unequal cost, weighted load balancing. And yes, you can do that. And part of this is already there in our implementation. The other thing is, if I want to create 4 LSPs, because these LSPs are big, so I want to break it down into 4 LSPs, and I don't have 4 equal cost paths that I could use, then in principle you could use 3 lowest cost paths and then 1 which is slightly higher cost, because you want to get to 4 for whatever reason. So the requirement for being equal cost and the requirement for being equal sort of partitioning of traffic are both not there. It's sort of up to you when you do the calculation. Can you do the calculation?
Okay, thanks.
So the name equal cost is a little misleading because they can be unequal costs.
Well, it's unequal cost, and it could be also unequal load balancing. So yes,
Yeah.
It's maybe we'll just change it.
I mean,
to
the draft
load
points out that that's a
Yes.
you can do everything ECMP does and more. So
Yes, yeah.
But there's a place where you're talking about SEROs, and I got confused exactly how the containers work. Are they separate tunnels that are bound together, or are they?
Yes, they're separate tunnels. It's very analogous.
So it should be ERO rather than SERO.
Yes.
Okay.
Yeah, possibly. I'll go back and look why we use that. But the idea is very similar to sub-LSPs in a multi-point LSP, except here they eventually do merge. So, but I'll check why we use SEROs.
Do they all have the same tunnel number, or they have different tunnel numbers?
Different tunnel numbers.
Yeah.
They just have an association object.
Yeah, so that's different than
Yeah.
point to multipoint.
Yes, no, it's not. I'm just
I
saying
was also
analogous.
worried about, because the sub-LSPs are also used for regrooming in some implementations anyway.
Oh, okay, yes.
It's also written down in 3209.
Right.
That way, so I was worried that we might overload that, so I'm glad you went to the association.
Yes.
The only other comment / question is one of the biggest things that we face as a vendor is people pushing midpoint scale, and this would appear to push midpoint scale higher. So I guess it's a buyer beware kind of thing that needs to be added to the draft.
True. So in our implementation where we do the computation, we let you set bounds on how many LSPs you want to create in the container LSP. But even when we didn't do it, other people are doing this on their own. They're just doing it manually. They're saying, I can't place an 80 gig LSP. I've got 80 gig of traffic, so I'll create 4 LSPs anyway.
Right. No,
So-
no, I'm not arguing with
Yeah,
draft.
no, I understand.
I'm just saying that maybe there should be a comment in the document somewhere saying that, when you do your planning, you should take this into consideration.
Sure, okay, we'll do. Okay, what happened here?
I'm cutting. Eric Osborne, level 3. Just, George, to your point about scale, I don't know if this changes scale necessarily much, because what Garidi is giving us is something we do manually now. Which is take a big bandwidth chunk and just cut it in quarters or whatever.
Right.
The possibilities there to turn into lots of little spaghetti pieces, but that seems like an implementation question.
Yeah.
A couple questions. Luberger, what's the format of the association object you're using?
TBD.
It'd be good to write it down.
Okay.
Particularly before you ask for code points for it.
Okay, sure, yeah, okay.
So, and there is a follow-up. Looking at the IANA section, I know I've done that before. I had the same comment then that I have now. It's fairly bare. You
Yes.
can hardly
Ask for-
understand where you are going to look for, where you pick the code points.
Right.
So if
right.
you closely meet during the week, we can kind of set it up and kind of put text there.
Okay.
Otherwise, the request that you need to send in for early allocation will actually just fall flat.
No, I'll do both. What Lou suggested is to make sure that I know what format of association object I want, and also fill out the INS section. So do you want me to do it this week, or reissue the draft with a better INS section?
If you make a request for an early allocation, I will go back and send the draft back to you and say, explain what you want.
Okay, okay. All right, so I'll update the draft and then send the request,
Yeah.
make a formal request. Cool. Next slide. No, next deck. Yeah, I did those on my Mac, so I gave you a PDF. Yeah, I did them on my iPad. So this is the labeled art draft. This one also has been around for a little while. At one point we had a lot of discussion. So, and yeah, next slide. You can see here that George is a co-author. You should have known that, but next slide. So there were a lot of comments on the list. I think we've resolved, at least we've addressed all of them. I've been told that we haven't necessarily resolved them. The big one is how to allow for a IPv6 address. So my answer is there's a protocol ID field, and we'll put the ether type for IPv6, and we'll set the byte count to 16 and ship out the LOP request. So works for me, I know, but I was told that it may not work for everyone. We don't need all the machinery around ND. We just want, this is literally an ARP request, address resolution. I'm going to give you an IPv6 address I want to label. In general, we can also reply with the label stack. So we think that that's a reasonable solution to the IPv6 question. There's also a question of can you reply with more than one label? So if it takes me a label stack to get to a certain place, can you reply with that? To do that, I decoupled. I initially had the target hardware address, which is where the MAC address used to go for Ethernet, to be a MAC address followed by a label. And you have a source and a destination. You don't need the source. You just need the destination. And then with the label stack, you're wasting a lot of space potentially because there's only one field for the length. So if you say this whole thing is 50 bytes, you put empty 50 bytes in the source target address, and then you put the real 50 bytes in the destination. So I peeled it apart and said the source and destination targeted addresses as just max. This is specifically for LARP over Ethernet. I mean, if you want LARP over some other medium, go for it, write your own draft. And then there's a TLV at the bottom that says, here's what we're going to do for the label stack. So it's n by 4 or n by 3. And then here's what the metric is, just in case you want to use a metric field. So we peeled out the metric and the label stack into separate fields that go below the regular MPLS, the regular ARP reply. This is the approach that was taken by the ATM ARP guys, so I figured that I'm not blazing new ground. Okay, so for this as well, if there are more comments on the list, if there are comments about IPv6, direct them to my co-author here. Thank you, George. And if there are comments about anything else, direct it to any of the authors. And the second request is to make this a working group document.
Which I can't answer.
Yeah, you can recuse yourself.
We have a question.
Himanshu Shah. I didn't quite follow the need for label stack on a same subnet when you're doing an ARP. Why would you need a label stack?
So this is not an ARP really, it's a proxy ARP. So it's not the same subnet. So imagine a server is talking to a TOR, a top-of-rack switch, saying, hey, there's a server at the other end of the world, and I want to get there. How do I get there? It might be a single label, it might be a label stack to get there. So, and the power of MPLS is stacking, so why not use that? Why hide that from this? Questions, comments? Huge support? Okay. Next one, yeah, please. So this is actually a PowerPoint. Okay, so this is an update on this thing called resilient MPLS rings. Next slide. You've seen some of these slides before. I've tried to compress the part that you've seen before, but I wanted to emphasize this part because I'm going to show you now there's more meat behind the part that says you don't need to configure as much as you did before. So the theory here is you don't configure LSPs, you don't configure n squared LSPs, especially if you're using RSVP on a ring with n nodes. You don't configure bandwidth. So there's a number of things you don't configure. What you do configure is, I want an MPLS ring. And even for the configuration of the ring, we've simplified that considerably by saying that you can configure as little as 1 or 2 nodes on the ring, provided the rest of the nodes on the ring have a certain property. Then we've talked about protection, but there was some discussion on the list about protection, so I'll talk a little bit about that. And then the last part about not configuring hierarchical LSPs, I haven't yet put in the draft, but it will appear shortly. So next slide. So let me go into some detail on how you configure a ring. So if you look at this ring, what you see is actually it doesn't look like a ring. I mean, there is the outline of a ring, but there are lots of links which, if you think sort of intuitively, the octagon is the ring, and then there are a bunch of other links that are bypass links. And then there's these random cilia sticking out of the ring, which are the non-ring nodes, non-ring links. So if you look at the bottom, right now they're all unidentified. You don't know what is what. But eventually, you want to classify them as a ring link, as a bypass link, and as a non-ring link. So in the simplest form of this, you configure 1 node. Now, when I say configure 1 node, people get nervous, so I'm going to say here, configure 2 nodes. And actually, there might be a reason to do that. So in this case, you'll see the top 2 nodes, which you see the circle on. They're configured as ring ID 17. So basically, rings are identified by a number, 32-bit number. So this ring is ring 17. The condition for being able to do this and not having to configure any other rings, any other nodes, is that all the other nodes can only be possibly on one ring. So all the messages that they get from any of their neighbors will say, either it won't talk about rings or will say, I'm on ring 17. If there's a confusion that, say the second node there, the one after the 17, clockwise of 17, says, I could possibly be on ring 17 or ring 19, that confusion means that you should have configured that node. There's no way for it to figure out whether it should be 17 or 19. Now we're looking at algorithms that might get past this, but for now, if you have a ring where the top two nodes that are marked with a circle could be on multiple rings, but all the rest of the nodes on this ring can only be possibly on ring 17, then you don't even have to configure those. So the other thing is, and this is not a requirement, but this is a strong suggestion, interfaces are unnumbered, bundling is automatic, so if there are two or multiple links between the same pair of nodes, they're understood to be bundled, which means that if I send a path message on one, I'm actually sending a path message for all of them. And the IGP is used to do all the auto discovery. So all the heavy work of configuring all of this is done by the IGP. Next.
Can you break that apart?
Can I break what apart? The IGP?
No. The bundle.
The bundle. You can. So the default is, at least my thinking is, that the default is all of this will happen automatically. If you want to configure an IP address or a subnet on links, you can. If you want to declare that certain part of the bundles don't have to be, are not part of the ring link, you can do that by configuration. Absent configuration, it's going to take the entire bundle. But the other thing, which I haven't gone into in this, either in this slide deck or in the draft, but I will address at a future point, is that I don't want a ring link to be dedicated to a ring. So imagine that you had two octagons kissing, right? Yeah. And you had this link in parallel. And let's say there was just the one link. It can be part of both rings. It might be clockwise in one ring and counterclockwise in the other ring. And then you just have to manage the bandwidth on that carefully. So you shouldn't try to put too much bandwidth on it. But there's no reason why that's now dedicated only to ring 17 or only to ring 18 or whatever the other one is.
But if somebody wanted to...
Again, by configuration, you can override it. I think that in routing, we have a philosophy that unless you configure everything just right, it won't work. And I know that on our boxes, it is very true. And so I want to get to the point where the basic thing works correctly. So taking principles from SON, self-organizing networks, and if you want to make it do different things, configure it. But if you want it to just work, well, we'll try to make it just work. Greg?
Yes, Greg Mirsky Erickson. Kiriti, amazing progress.
Thank you.
Great document. I have a question. So, especially in regard of promiscuous mode and explicitly configured. So you have a...
Could you wait until we go through the next slide?
Okay.
Go ahead.
Because you kind of implied that it's okay because you mentioned that zero RD, ID, and specified ring. So there is a T1 timer that you mentioned. Is there any default value associated with it? Because it defines the period of ambiguity. And what happens if past this ambiguity, previously zero timer zero RD node will see another ID identified? Should they withdraw with it with their identity is assumed, or it's already now become sticky?
So I suggest that Karini continue with the presentation, and at the point where he's got enough background to answer your question, then he answers it then.
Okay, yeah. So next slide. So here's how this would work, and so there's a bunch of animation. Can you click once? Essentially, you're going to announce the ring nodes that you see with the circle on them are going to have an RID of 17, and so they'll announce that in the IGP. And so what happens then is, take the next node, clockwise from the second 17. That guy is going to hear that an IGP neighbor has ID 17. It itself has ID 0, meaning it's part of a ring, but it doesn't know what its ring ID is. So it's just going to, like a chameleon, it'll absorb that color. So it'll say, I'm going to be 17. And so then it will, so if you're a promiscuous mode, that means your ring ID is 0. You don't announce your ring ID. You don't have anything to announce. But this node here, which I should have given a number or name to, when it sees that its neighbor is 17, it's going to announce that it's 17. So it becomes 17. So when that happens, the next guy will say, hey, now I have a neighbor who's 17. Actually, he will already see that because of the bypass link. So the next node will also say, hey, I'm 17. Now, because of that, this node down here, either because of the second node or the third node, the node down here is going to say, I'm 17. So what you'll see is this sort of around the ring in both directions. I just had the two nodes that were 17, but eventually everyone says, I'm in ring 17. To make all this happen, you make your announcement and then you wait a certain amount of time, and there's a timer T1 that Greg just talked about. And in that time, you'll see, did I hear anything else? And if I didn't hear anything else, you say, yes, I'm in 17. But if you hear something else conflicting, you say, no, I'm confused, and I'm going to stay confused. And to your question, if after the timer goes off, you later learn of some other guy who says, hey, you might also be in 18. The answer is you withdraw. You say, I'm confused. I thought I wasn't, but now I realize I am, so I'm not going to be in a ring. So if you see something like this, if you imagine multiple rings, if this is an access ring, you have these two hub nodes at the top, the ones with circles on them, and you have multiple rings going through them, but they're all independent after the hubs. That's why you configure the hub nodes to be 17, 18, 19. But everything on the rest of the ring, if there's only one choice that they could be in 17 or 18 or 19, they have no problem then.
Okay, so if in the case of interconnected rings, so you envision that these nodes that are interconnecting two rings will belong to two different rings?
Well, if you imagine this this ring and a ring right next to it, or up, yeah. Wherever you have a node that's part of two rings, you configure it. And you say, on this interface, you should be ring 17, and on that interface, you should be ring 18.
Okay, so basically, because that's what I was implying in the question, would this dual or multiple identity node advertise itself on all other rings but the ring that you want to?
So you have to tell, so if you think of this node, as you said, there's a ring above, there's a ring below, but there could be also multiple rings below.
There could be rings on the left and the right too.
Sure, but let's just start with that case. You would say, make your advertisement for these interfaces with 17, with the other interfaces with 18, and for the one above with 22.
So that makes RID interface property, not the node property.
Yes, and actually right now, I was having a discussion with some colleagues, and right now I have both a node property and a link property, and they convinced me that I should remove the node property. So maybe we'll end up having just a link property.
I do agree.
Okay, good. So that's the announcement phase. If you click through.
I have a question.
Yes, please.
So there are, how do you figure out what are the bypass links and what are the
You'll
links?
find that's coming. Keep going.
Okay.
So the next thing is I have two nodes that had circles on them because people are nervous if there's only one point of failure. And typically, when you build these multiple rings, you will have two nodes that are common between the different rings. So one of them has to be elected master because he's going to start the process. And so that's a simple mastership thing. And then after that, you have the ring identification. So this is the question that George asked. If you look at this, So you have the ring master, that's the one that with the purple circle around it. It's going to say, okay, I'm going to look at everyone who says that they're in my ring, and I'm going to compute a path that goes through as many nodes as possible. So for example, if it takes the yellow link that you see here, or yellow-orange link, and then takes the rest of the black links and the blue link on top, it's a ring, but it's a ring that has left out one node. So that's not a maximal ring. On the other hand, if it takes the blue link that goes to node number 9, it actually will find a maximal ring. So you have to do a computation, especially if you look in your IGP and you find exactly 2 neighbors, you're good. Your life is set for you. If you find 1 neighbor or 0, you're really sad, and maybe you need to go on Facebook and find some friends. But if you have 3 or 4 neighbors that are next to you, then you need to figure out which are the 2 that I'm going to use. I need a clockwise and a counterclockwise neighbor. So in this case, picking the yellow would be a mistake. Picking the blue one to node 9 would be the right one. And so this is how you distinguish the ring links from the bypass links. So let me say it again. You compute which are your clockwise and anti-clockwise neighbors. You pass on to the clockwise guy, hey, you're my clockwise neighbor, so now you do the same, and that computation goes down the ring. When you're done, you have all the blue links, which are the ring links. Every other link that connects 2 ring nodes, which are not defined to be ring neighbors, becomes a bypass link.
Okay, I just want to observe, I guess, that the diagram you have has 2 maximal rings in it.
Yes, the next slide shows you that.
Okay.
Yeah.
Good.
So at the end, we've taken all the unidentified nodes and essentially said, actually there's one more step, because the links that are sticking out of the ring are identified as non-ring links, because they're between a ring node and a non-ring node. So essentially we've gone from these black links to...
Slight correction there. It's a ring node versus a node that's not part of the ring. Could be a ring node of something else.
Of something else. Yeah, thank you. Yeah. So we've identified the ring links, the bypass links, and the non-ring links, or non-part of the same ring links. Yeah, so the red things will be identified as nodes from this ring node to maybe some other ring node or not a ring node. Greg?
Okay, so this is an auto-discovery process.
Yep.
I just want to ask, would that be a discussion of manual switchover?
Manual switchover for?
For node removal and insertion.
Yes, so that is coming. It says somewhere in the draft that, what happens if there's a change in topology, to be defined. So if I insert a node, if I remove a node, how does it self-discover that too? I think it can be done. I want to start with this as a baseline, but the answer is yes.
Okay, but the question is that, okay, it's from operational, that has to be done first by locking it out of service and then reconnecting into the service.
So I'm not sure, but...
because otherwise you're creating the fault. When you, for example, you remove the node, you're creating the fault. And opposite to that, to be in controlled manner, when you do the lock the service, you do the switchover, and then you can do manipulation with your topology, and then re-enable the service.
Yeah. So for removing a node, yes. For adding a node, you might be able to do it in service. Actually, I'm talking with someone who, on the service provider side, who is supposed to go and figure out from his operational folk how they actually add nodes, and then use that as a baseline to trigger how this would work. But anyway, this is future work.
Okay, thank you.
So curious to Sharon about. So actually here in this case also you can have multiple rings selected. For example, 1, 3, 2, 4.
Can you wait for the next slide?
Oh.
I think it's in the next slide. Can you? Yeah. So this is exactly what it says. So it is a choice of the node that has to do the computation. That, if the flag is passed to you and you have 3 neighbors, you could pick, and for example, in this, just exactly this, you could pick that. And so it's up to ring one, to node one, to say, is 2 my neighbor or 3 my neighbor, right? So, yeah, it can be done. So, and you might have, I mean, ideally you don't have metrics on these because you'll just, or you might define the metrics by length or define the metric by various things. So you might say, oh, because of metric, I'll pick 2 over 3, right? But, you know, they both work. It's topologically the same.
So, Karidi, when you talk about a maximal ring, I'm assuming you're maximizing the number of nodes in the ring. You're not maximizing the metric cost of the ring.
No, the maximizing number of nodes, yes. Yes. So, so that was...
Kennedy, you are a little bit short of time.
Sure. This was the main thing that I wanted to hit. Next. So we can skip this. You've seen this before anyway, so please go through all the... there's one thing here. Once you know what your clockwise and anti-clockwise neighbor are, in principle you can start signaling right away. You can wait until you see that everyone has a defined clockwise and anti-clockwise neighbor, and then start signaling. But you signal based on the fact that the ring is identified, not because someone gave you configuration. If you're on a ring, there's not really very exciting EROs. There's the clockwise and there's the anti-clockwise. There is the question of how to use the bypass links, and that is a question also to be resolved in the future. But in general, the ring LSP, which is the one that starts at a node and goes all the way around back to itself in both directions, that can be kicked off as soon as you have a clockwise and an anti-clockwise neighbor. And path messages are only sent clockwise, and RESVs are only sent anti-clockwise. And then for the RSVPTE guys in the room, close your ears while I say that you can send a RESV before you get a path for it. That's what ring identification is about. But anyway, read the draft. So pretty much that's, there was a few comments on link protection versus node protection. For me, in general, link protection and node protection are the same. The only time it doesn't work is when the node that fails is the end of the LSP, is the egress, because then you'll have, as people pointed out on the list, looping. And so we have a couple of solutions to that. They're written in the draft. At some point, I think we need to decide which is the one we want to go with, or at least the recommended version, and then either remove the other ones or move them to an appendix, or keep them there but as secondary options. So that's basically what I had for this. We have a new author, and I think we'll get a few more authors. So you can skip through these. I don't know if there's a last slide. One last thing is, again, for the sake of minimal configuration, as soon as you start signaling LSPs, you'll also start link level OAM. And in the IGP, it gives you a choice of, what OAMs do you have. I probably have to increase the list, but you start link level OAMs right away. And default timer, we'll pick a number, but 3.3 milliseconds seems to be a favorite one. And of course, everything can be overridden by configuration if needed. Yeah, so it's up to you now, because the rest of it is about LOA. Whether the MPLS working group should be working on this, and what we should do with the 2 drafts that we have. I put my choices there, but...
I think we have converged on merging, at least, and the rest...
Converged on not merging.
We have converged on the question of merging,
yes,
that we won't merge.
Yes.
Okay. The other one is fully up to the MPLS working group process, starting with the IPR polls and things like that. MPLS RT review and adoption poll.
Yeah.
And that goes equally for both drafts.
Sure. Okay. Okay, thank you. There's another question. I don't know, time and...
Eric, I'll know, it's a real quick one. The question should work on rings. I mean, we did 6974, 2 years ago. We've already done work on rings. It seems to be within charter because it's been done. there's this applicability statement. I'll bring it up when we talk about the Cheng as well. But there's some history in doing ring work, I think.
One ring to rule them all, right? It had to come out sometime.
Well, now we're up to 3 rings.
Robin from Huawei. I have 3 comments. The first, in fact, before the topic is proposed in the IETF, this topic has been done much research in our team. I like to propose 3 comments. The first one is that the ring topology is beyond, is not regular always, because this I have been proposed in the last meeting, because I think the ring topology is always related with mobile backhaul network, and the mobile phone is always distributed, so the ring topology is always irregular. So I think here the regular ring topology may be no issue, but I think for the irregular ring has many issues. For example, I think Greg proposed the intersecting rings. I think that is one example. This is your first comment. The second comment, I think that's for the irregular rings, I think the most important challenge is not only for the IGP. I think the most challenge is for the RSVPTE. I think a lot of the behavior of the existing RSVPTE message should be modified. I think this may be not in the Mpls working group, but also in the TES working group, but also it must be taken into account about the compatibility issues with the existing RSVPTE. The second comment. The third comment is that regarding the ring topology, I think if we want to solve this issue, I think regarding to the complex ring, I think the only possible way is to use the static configuration, configure the label and configure the protection. I think this is a feasible way. On the other hand, if we want to use a dynamic protocol, we think the better way, I think the existing way has been proposed. I recommend that's the MRT based on the LDP multi-topology. Because use the MRT, the ring topology is based on the MRT algorithm. It's easy to calculate a clockwise ring, and is another protection is counterclockwise. So, and also the label is advertised in Mpls LDP multi-topology. It can easily solve the issue in this, proposed in this topic. I think that's maybe the better way, or else there may be much change to the IDP and RSVPTE.
We'll cut the line after Stuart.
Okay, so let me answer the first point. If you have what you're calling an irregular ring, or rings that intersect, or any such thing, all you have to do, you can't necessarily have, especially the intersection points cannot be promiscuous. They have to be configured. The rest of the rings probably can be configured, but the intersection points, wherever you have 2 rings possibly at the same node, you have to configure that node to say where which is ring 17, which is ring 18. To the point about RSVPTE, the proposal for RSVPTE extensions is going to come. What I wanted to do is to motivate the problem and show how the auto discovery can be done. For the point about IGP extensions, the goal for IGP extensions is really to make the configuration of the ring much simpler. So you don't have to go to every node and configure it. It can be done automatically. So that's the motivation there. And by the way, yes, there will be new RSVP path messages and resume messages. And if Tees is the right place, that's fine. But there'll also be LDP extensions. So if you're not interested in bandwidth, you can do LDP on this as well.
Kriti, try to keep things short because you are over time.
I'm done. Yeah. The last one about MRT, I'm not going to talk about. So next.
Bing Wen from Comcast. I have a couple of questions. First one is if you go back to the topology, what happens when you between 7 and 4, you have another router there?
You turn off node 7 and node 4?
No, so like in your topology, if we can go back to the slide, right? So right now you have a link, you identify a bypass link between node 4 and 7.
Yeah, yeah.
So what happens in the physical topology? Actually, I have another router, say router 10. So in that case,
can you keep going? Keep going back.
So that's not a simple just bypass link. So how do you complete the ring?
So if there's a fault, you have a fault. If you have a bypass ring, you might be able to say, I'm going to recreate a new ring which is smaller than the original ring with the bypass in place. If you didn't have a bypass, you just use ring protection. So the fact that you have a bypass will allow you to reconstruct some of your ring. But for example, so you said a fault between which?
4.7. So if I have another node here. So do you, first of all, is there like a master ring and a sub-ring concept? Like the master ring, I would assume you're going to finish the, complete the ring topology.
Yeah.
The sub-ring can be like attached to a master ring?
Yes. So if for example, the link between node 4 and node 5 were to break, I can complete the ring using the bypass between 4 and 7. But then I'd have to do something special to reach 6 and 5 and 6. I think we should probably take this offline, but how you use bypasses and what you do in the case of failures in the presence of bypasses is definitely something that I'm willing to have more discussions on. I won't say.
One real last question. So can any given link be a member of multiple rings?
Yes.
Okay.
Yes. Yes. And of course, any node can be as well.
Okay. Stuart, try to keep it short or be a pointer to offline discussions.
I'm rather sort of curious about something here. So in all the sort of ring technologies I met in the transport space, no matter what nodes came up, they would make the best of it. All right. And in classic networking, that happens. I'm rather curious as to what this thing does if some of the links don't come up to start with, whether it's still capable of figuring out that it's got a fragment of a ring and operating just around the arc.
Well, clearly, if that happened after the full ring came up.
No, before.
I understand. So one thing you could say is if I detect that I have a fragment of a ring, I will still go on with this, but I'll pretend that it's a ring in failure mode. One of the problems with that, at least one of the problems with my current approach, and talking with my colleagues that are pushing me in a different direction, is the ring identification proceeds only clockwise. So then it will run into problems if you do that. They're suggesting we go both ways, and that would, I think, solve the problem that you'll at least identify the fragment, the maximum fragment that you can, and then you can pretend that that's a ring, it's an impaired ring.
Okay, we've now spent well over half an hour on this.
Okay. Yeah, we're way over time. I do have some questions for you, but I'll take them offline.
Sure.
But thank you for a very interesting presentation.
Thank you.
So, Leon? With the sharing.
I'm Liang from China Mobile, and I'm a colleague of the first author listing here, Wei Chang. And to my knowledge, the shared ring draft has been around in the IETF for quite a while, and personally I think it's in a pretty good form now, and I would like to briefly review, and by the way, I thank Kiriti for his brilliant presentation for the ring. It's a really good tutorial, so we don't need to talk about the basic ring thing very well in my presentation. So we'll just briefly go through what we're talking about in this draft. So please, yeah. So there's some essentials about the shared ring technology, shared ring draft. So we define ring internal structure and specify the data plane of the ring. And the ring protection mechanisms, we have the protection ring internals and we have the working ring internals. I'll talk about these in more details, how we create this in the next slide. The ring internal here, if we look at the graph on the left or right-hand side there, the ring internals in our ideas is purely created based on the exiting node. So for example, for D, we create clockwise and anti-clockwise working ring internals and protection ring internals. So there are 2 pair and 4 independent ring internals altogether. And in this particular example, you can see the working ring internal going from E to D, skipping D to E, and the protection internal is a closed ring internal from D to D, going anti-clockwise. So next, please. And you can go for skip the animation thing. Yeah, so if we have a traffic entering the ring from A, and first of all, if we have a failure from B, between B and C, the B node was, okay, there's a failure, I'm going to switch the traffic to my protection terminal. So swap switch the traffic anti-clockwise to A, and then it's going to the next node, which is C. So in this particular case, when the traffic reach E, if we have another failure between E and D, then E E is not the destination node, and it's not the next node, which is the C. So E will say, okay, there's another failure avoiding me going to the correct node. So to prevent the loop, I have to discard the traffic. So what it's doing here for E is to discard the traffic here, so preventing the loop. Okay, next please. To have 4 independent working and protection terminals, can easily to manage the bandwidth completely independently, and that's why I put a slide here. I'll just skip that. Yep, so we talk about the ring protection. Here is the wrapping situation where actually I have talked about in the previous slide. So the same situation, we have a failure between B and C. So the traffic going from A to B and then switch the protection anti-clockwise terminal. And it has to reach C because the next node of the LSP is C, even though it actually go past D, which is the exiting node. So from C, it switch again the traffic from the protection terminal to the working terminal, and then finally reach D and leave the ring. Can you go to the next slide, please? Yeah. And we define a short wrapping situation where D as the leaving node is smart enough to know that the traffic on the protection terminal not reaching the next node is actually going through the leaving node. So I'll stop the traffic, and because I know the traffic is actually leaving from this particular node, so the traffic does not need to go to C and then back to D. It's directly leave the ring from D node. Right. And steering. Well, again, the situation is a failure between B and C. Here, B, we make all the nodes report failure to the neighbor node. So the entering node A knows that there's a failure associated with B. So the traffic won't be going to the wrapping situation we're talking about in the previous slide. It directly going anti-clockwise on the protection terminal to the destination node, leaving the ring. And here we mentioned that extra time would be needed because the B need to report the failure to A node in this particular case. Okay, next, please. We briefly talked about the section OEM, and between 2 adjacent nodes here in this ring, And we believe it might minimize the amount of OEM entries compared with the LSP level OEM. And to implement this, please go next slide, please. We define the RSP protocol. It's basically a message between the adjacent nodes using the section OEM. Okay, I'll skip that as well. Thank you. Well, this is just a brief review of how this document has been discussed in this group. Next, please. Basically, there's not much controversial changes made in the updated version. We reorganized the statement for improvement of the readability, and there were some editorial changes as well. Yeah, so next, please. So the next two slides, I won't spend much time on it. It's really just some implementation work we've done in China Mobile. This is a lab test. We demonstrated that the protection can be established within the order of tens of milliseconds. The next, please. Yeah, that's just demonstration of the future. I'll skip that as well. Thank you. So for these draft, we would like to request consideration of adoption of working group document. And also we would encourage all the colleagues to read a draft and make comments so that we can improve it. So yes, that's pretty much about the draft. And any questions?
I have a quick question on the short wrapping. Is it, if you can go back to the short wrapping thing. No,
no, previous one.
Yeah, this one.
No. Yeah. Whoops. No, next one. The next one. Yeah.
Is the decision to short wrap or long wrap taken by B or by D?
Oh, the decision. Well, the decision should be made by D.
By D.
Yeah.
Okay. Thank you.
And what does D decide upon? Sorry. How does D decide?
Well, because D knows that it's not the exiting, but it's not the next node. C is the next node on the LSP.
Yeah. So how does he make a decision that he's going to take traffic off of that and it's going to leave the ring?
No.
Yeah.
Yeah, I can tell you. I think maybe I know.
Yeah.
So I've read this draft many times. It's a different LSP. It's different from the previous one. It's node B actually puts it on a different.
Node B made the decision.
Yes.
Okay.
Yeah. So that's one, and I think I know that Kireti doesn't like it, but I think from at least the short wrap part is pretty much identical to Kireti's data plane from data plane. I don't know. Yeah. Control plane is completely different, but data plane is completely identical. So there are a lot of similarity between these two. I know that he doesn't like, but if they can merge it, it would be a good idea. Otherwise,
So
only if you would like to wait until 2020 to see it.
That's fine. So I mentioned earlier RFC 6974, which is an applicability statement for PSC that talks about how you do steering and wrapping using PSC. It doesn't talk about short wrapping, but it seems the same kind of thing. I think this draft needs some section that covers why that's not good enough. We already have a method to do ring protection. Okay. Protocols we're already shipping. This is sufficiently different, especially when you look at, or it overlaps quite a bit if you look at the guts. I'd really like to see some text describing why this needs to diverge from that approach.
Yeah, I think this is very good comments. I really apologize that I'm quite new here. I haven't read the RSC that you mentioned. Sure. I'll have a look at it, and I'm sure that there can be text describing.
It's got to be a scale analysis or something, because a lot of what you have under the covers is what PSC has. I'd just like to see.
Yeah.
So, Eric, a quick question.
Yeah.
Since you mentioned it before, in discussion with Kuret, is this something you actually require on both drafts? Or is it just a...
I didn't ask for it in Carides because Carides is sufficiently different that to me, it's on its face, it's obviously different. Whether it's better is a different question. This, if you look at like the alarm hierarchy you have, very clearly it's the same level of alarm hierarchy. It's the same information is propagated, but it's got a whole new protocol. I understand there are ring scale differences, and I've seen some docs a couple of years ago that spelled this out, but this overlaps so much with what PSC does that I'd really like to see that delta called out. If Karidi wants to write something too, I'll read it. I can stop.
Is Greg Mursky around as our next speaker? I'm just thinking you might as well come up here since we're running a little short on time while we take a last question. And try to keep the questions short.
Okay, I just Robin from Hami. This is just the quick comments. I think this based on this figure, I wanted to go on to explain the difference of the static configuration and the dynamic. Because if in this way, in the static configuration, the traffic switch only in the forwarding plane. But if you use the dynamic, not only the forwarding affect the forwarding plane, but also the control plane. Because the existing RSVPTE is dynamic allocate label, but in this case, it, in my opinion, should not release label, even this failure happens. So I think that is why I think dynamic protocol may have much change. Yeah, that is just regarding the first, the Mpls draft. I want to add these comments.
Okay.
Good. Thank you.
Thank you.
Thank you.
This is update. This draft was mentioned in the status. We have joined our work with the, can we go to the next one? With the authors of draft that was addressing similar problem, and welcome Mac to work with us. So their update that we put in this in this version is that to add the new return code when their recommended return path cannot be found. There are two scenarios that we consider now in the document. The first is that when a far end node decides to use return path over IP data plane, and 5884 then makes it optional to use LSP echo reply. In that case, we make an optional that egress may use return code return reverse path not found to respond to inform the ingress. If their far end node, egress node, decides not to use LSP and thus BFD session would not be established, we state that egress node must use echo reply and must use new error code requested reverse path not found. So we appreciate all comments, and in our discussion we agreed to change some terminology in our document. So now we use ingress egress. Next slide, please. So this is explains what we've done. Next slide. Yeah, we can go. So this is just a use case that we added to illustrate how it works and when it might be useful if we have alternative path. So the return path, as stated in the use case, can be used always by their to follow best route over IP, and if we want to have to minimize the number of possible false negative and positive negatives, then we can control the return path, and we can make as option return path to be correlated with the forward path of the UFD session. We can go next. So the next steps, we always welcome comments from the working group, and we think the document is stable enough, and we would like the working group and chairs to consider adoption.
So, questions? Okay. Greg again.
Yeah, next. Yeah. Let's keep moving.
The one you just talked about? No? The one you just talked about, or the next one?
This is update on a document that we introduced several meetings ago. We took a briefer on Honolulu, and now we have quite substantial updates to the document that we'd like to present to you. So in our update, we welcome Eric Gray to the group of authors. And objects that being defined that residence time measurement, ACH encapsulation, PTP packet sub-TLV, capability advertisement in IGP traffic extension protocols, and RCPT RTM set object. And we introduce, and now we have two modes for residence time measurement. One we refer as a one-step, where there are message that carries 1588 or time synchronization protocol carries their correction, and another when there is a follow-up message that carries correction, and we can discuss it further in the presentation. Can we go next, please? So the ACH format now, we went through several versions, and we ended up in a generic format that uses ACH encapsulation and has scratch pad of 8 bytes, which is consistent with the correction field in 1588 version 2. That is the only current protocol that has any correction field that accounts for residence time in the node. And then it has a TLV structure, and TLV structure is a pack and can be used to carry either their time synchronization packet or some other information. Can we go next? Their PTP or 1588 version 2 protocol will have its own sub-TLV, which is carried in TLV field of ACH encapsulation, and it has some characteristic information to support transparent clock and RTM measurement. Yep. So this is more detailed description of what our fields are in PTP sub-TLV. In order to support it in heterogeneous environment where not all nodes are RTM capable, in RSVP to calculate explicit path through RTM capable nodes and calculate properly TTL value to do their RTM calculation. We use IGP extensions to advertise RTM capability. RTM capability will exists in the format of ingress and egress capability, because in some in our discussion with their vendors and in some forwarding engines, it's challenging to do timestamp on a transmission, on a packet that's being transmitted. And that is where we have two modes of RTM. And it's similar to one-step and two-step time synchronization used in 1588. So when there correction being sent in the follow-up message. So in applicable to RTM method, what is envisioned that it's much easier to take a timestamp and transmit the timestamp in a follow-up message, and that would be a two-step mode. In one-step mode, the timestamp calculator will be adjusting their correction field in a scratch pad in a same encapsulated packet. But in a two-step, there will be a follow-up RTM message that will carry this corrected field. And the RTM setup sub-object will be used with the ERO to calculate properly TTL values so that ACH RTM message can expire on a proper RTM capable node, ensure RTM, well, resonance time measurement. So this to illustrate one-step mode when their 1588 message arrives at the ingress OSR. It's encapsulated in RTM ACH and being transported. The path is being set through RTM capable node, and each RTM capable node calculated the TTL value to the next downstream RTM capable node, and that's what it does when it sets their TTL value. So their TTL expires to the next node, and their ingress timestamp is taken, then the node is forwarded, their egress timestamp, so they subtracted their value added to the scratch field, and then RTM ICH packet arrives at an ingress OSR, so and that scratch pad can be used to do correction field in 1588 packet. We can go next. It's a little bit more complex with the two-step mode, because in the two-step mode, so what we're assuming that there will be RTM message that carries their 1588 synchronization message, but because some nodes may not support updating the packet as being transmitted, that packet will be followed by RTM ACH encapsulated packet with their correction field that is related to their packet that being before. But their follow-up packet will have all the characteristic information of the packet it follows for the correlation. So it's a very similar to two-step process that is being used in 1588 version 2. We identified that there is some more work that we need to do, and we'll continue working on this document. Always welcome your comments and questions.
Sharon Duvari. So a question I have regarding that scratch pad format. Why is it IEEE double precision? Why not just nanosecond, as you mentioned, 64-bit, each bit worth in 1 nanosecond? It's more difficult to calculate. I mean, this gives you like many million years, even with everything as nanosecond. You don't need exponential and fraction.
Well, okay, it's a good question. We can discuss what the best format. Just looked at the same format that's being used in a correction field in 1588.
Oh, is it the same one?
Yeah.
Okay.
So it's ease of convergence. It's easier to apply their scratch pad to the correction field. But if there are other considerations, again, there might be some interest, we thought about it, that residence time measurement might be by itself one of their performance measurement that being done regardless of coax synchronization.
But by the way, we do have time to continue this, but I want to know where the other blue sheet is. Anybody have a blue sheet? Okay, and who has not signed the blue sheets? A couple of people up front. Okay, why don't you bring the one forward and then we'll continue with the questions.
Yeah, I think we have discussed this before, but as an option, if, is it possible to add a feature that every node can add the timestamp when it received that packet? So, so there's a linked list of, we know exactly the delays through each, from each node to the other node.
Well, I think that if there is interest, definitely in TLV.
Yeah.
Yes, we can define it. So it could be sub-TLV that be defined. So, as we are introducing PTP sub-TLV, we can define their time step recording sub-TLV.
Exactly.
Yeah. So, yeah, of course, if you have suggestion,
yeah. Okay.
Please. Okay. Thank you.
That's Chris. Okay, for anybody who's not signed the blue sheets, there's one here, there's one there, and thank you. We'll see you all Friday.
Kirete, can you come by? Your large craft. This is a no-go. Indeed. You need to cover that. But I think I want to help you on the probably something on